Hello students, in today's session we are going to find out the volumes of the combination of solids. So here we are starting with the exercise 13.3, question number 1. A solid is in the shape of a cone standing on a hemisphere with both their radii being equal to 1 centimeter and the height of the cone is equal to its radius. Find the volume of the solid in terms of pi. In this given figure, the hemisphere is there of 1 centimeter radius. Also, on the hemisphere, one cone standing on it with the radius 1 centimeter, and the height of the cone is also equal to radius 1 centimeter. So, radius and height of the cone and the hemisphere are 1 centimeter each. Now, by finding the volume, as we observe in this figure, volume of cone plus volume of hemispherical part is the volume of the solid. So, we add these two, as we know that volume of cone, that is 1 by 3 pi r square h, and volume of hemisphere is 2 by 3 pi r cube. By putting the values of radius and height in these two formulas and by adding these two, we get volume of solid is 1 upon 3 pi 1 square into 1 plus 2 by 3 pi 1 cube, and when we solve it, we get 1 by 3 pi plus 2 by 3 pi, and by taking the LCM we get 3 pi by 3, and 3 and 3 cancel out, we get pi is equals to volume of solid is pi centimeter cube. So here we can say the volume of the given solid is pi centimeter cube. Now let's take the second problem. Rachel, an engineering student, was asked to make a model shaped like a cylinder with two cones attached at its top end by using a thin aluminum sheet, as we observe in this figure. The diameter of the model is 3 cm and its length is 12 cm. If each cone has a height 2 cm, find the volume of air contained in this model. So by observing this figure, we get that the total height of the model is given 12 centimeter. So height of the cylinder, we can find it out very easily, as the total height is 12 centimeter and height of the cones which are attached at the two ends. So 2, height of this cone is 2 and bottom cone is also 2. So 2 plus 2 is 4. So height of the cylinder, we get 12 minus 4 is equals to 8 centimeter. Now it denoted by capital H. Similarly, the radius, that is equals to 3 upon 2, or we can say 1.5 centimeter. Height of this cone is given 2 centimeter. Now total volume of this combination of solid, or we can say total volume of air contained in this solid, is volume of cylinder plus twice of volume of cone, as the two cones are attached with the ends of the cylinder. So here the volume of two cones plus volume of cylinder becomes the air contained in this solid. Now by putting the values, volume of cylinder, as we know that pi r square h plus 2 times of volume of cone is 1 upon 3 pi r square h. Now here h and h are different. We are considering capital H for the volume of for the height of cylinder, whereas small h denotes the height of the cone. So radius, as the radius of both the solid cylinder and the cone are equal to 1.5 centimeter. So we can take pi and r square common from both the two terms. So pi r square is common. Capital H plus 2 by 3 small h is the rest quantity inside of the bracket. Now put the values here, pi r and capital H small h, we get 22 by 7 into 15 by 10 square. Now 15 by 10 we are getting the removing the decimal from 1.5. 8 plus 4 by 3. Now this 15 by 10 we can write it as 15 into 15 upon 10 into 10. And when we find out the LCM of 8 plus 4 by 3, by taking the LCM we get 24 by 4 upon 3, and this 15 and 10 both will cancel out by 5, so we get 3 into 3 upon 2 into 2. Now here we are getting this 2 divides this 21 11 times. So let us cancel out the terms which are cancelling. So this 2 divides 22 11 time, and then 24 plus 4 becomes 28 by 3. Here 3 3s are 9 upon 7 into 2. Now here also we can say this 9 and this 3 will cancel out, and 3 3s are 9 here. This 7 divides 28 by 4 times, and also this 2 divides this 4 2 times. So we get here 11 into 3 into 2, that is 66 centimeter cube. So here we can say the volume of the air contained in the Russell's model is 66 centimeter cube. Now let's take the next problem. A gulab jamun contains syrup up to about 30% of its volume. Find the approximately how much syrup would be found in 45 gulab jamuns, each shaped like a cylinder with two hemispherical ends with length 5 cm and diameter 2.8 cm. So here we have given the gulab jamun as the gulab jamun are similar to a cylinder with two hemispherical ends. So a cylinder with two hemispherical ends where the given total length is 5 centimeter. That meaning we can say the radius is 2.8 upon 2 is 1 by 4. So here 2.2 centimeter is the total height of the cylinder, whereas 1.4 centimeter is the total height of the, we can say, height of the two hemisphere attached with the two ends with the cylinder. So we know that the total height of the gulab jamun is equals to 5 centimeter and diameter is 2.8 upon 2 is 1.4 centimeter. Here, as we have written already, that height of this cylinder is, or height of the cylindrical part, as the total length of the gulab jamun is given 5 centimeter. So 5 centimeter minus radius of these two hemispherical ends are 1.5 and 1.4 and 1.4. That's 1.4 is the height of the hemispherical part also. So 5 minus 2.8, we get 2.2 centimeter. So here the height of the cylinder is 2.2 centimeter. Now the total volume of one gulab jamun, that is this volume of cylinder plus volume of two hemispheres, as we know that volume of cylinder is pi r square h and volume of two hemisphere, that is 2 by 3, or we can say 4 upon 3 pi r cube. Volume of a hemisphere is 2 by 3 pi r cube. Now here we have to find out the volume of two hemisphere, that is 4 upon 3 pi r cube. Now put the values. R is 1.4, height of the cylinder is 2.2 centimeter and radius of this hemisphere is also 1.4. By putting the values, and here 1.4 and 1.4 square is common and pi is also common in both the terms, so we take pi 1.4 square common. The rest of the quantities are 2.2 plus 4 upon 3 into 1.4. Now further, when we solve it, we get 22 by 7 into 1.96, as 1.4 square is 1.96. 2.2 plus this 4 into 1.4 becomes 5.6 upon 3. Now 22 into this 7 divides 1.96.28 times, and this in quantity inside of the bracket we take the LCM as 3, so it is 6.6 plus 5.6 becomes 12.2 upon 3. Now here 22 into 0.28 becomes 6.16 and 6.16, this 3 divides 12.2, we get 4.066. Now this product of the terms, we get total volume of one gulab jamun is 25.05 centimeter. Now this is the volume of one gulab jamun. We have to find out the 45 gulab jamuns. So as in the given problem, volume of sugar volume of sugar syrup is 30% of the total volume. So what is the volume of sugar syrup in 1 gulab jamun? That is 30% of 25.05. So we can say volume of sugar syrup in 45 gulab jamuns, that is 45 into 30% of volume is 25.05. Now we take this as 30% is 30 upon 100 into 25.05 into 45. Now we cancel out the 0 and 0, and also this divides 5 2s are 10, and this 5 5s are 25, and 0.05 we get 5 5s are 25.01, and 5.01, when we multiply it by 3 we get 7.515 multiplied by 45, so it becomes 338.184 centimeter cube when we simplify it. So we can say here 338.184 centimeter cube syrup would be found in 45 gulab jamuns.